All right, everyone, welcome. I'm Paul Lefevre, the Xojo Developer Evangelist. This week's webinar, we're going to talk about databases and specifically SQLite. And what we're going to do here is we're going to create a little database app. We'll describe a problem up front. We'll talk about how we would design a simple schema to solve the problem. We'll create a SQLite database based on the schema. And then we'll build a Xojo desktop app that will allow you to connect to the database, add data to it, modify, remove data, that sort of thing. And then hopefully we still have enough time at the end. I'll show you how you can quickly reuse most of what we have done in a web app. So like I said, quite a bit to cover. If you have questions, by all means, just type them into the question box while I'm talking. I'll see them over there, and I'll scan them periodically and try to address them as I'm going through everything. So without further ado, let us jump in here. So let's get started by talking about what problem we want to solve. And because this is my webinar, I get to pick the problems that we solve, and I try to pick things we can solve in an hour. So this problem, we want to create a little app that can track teams and the players on the teams. And I'm particularly excited about this because, as some of you may know, I'm a huge baseball fan, and last week the Boston Red Sox did win the championship by winning the World Series. I know it's not the whole world, but that's what they call it. So this little app here will allow me a chance to type in Red Sox player names, among other things. So you have teams, and you want to track all their players. So you have to think about how you want to design what is called a schema, or an overall design for this sort of thing. So I'm going to take a step back, and we're going to fire up a little tool here called OmniGraffle. And I'm just going to create a new blank diagram. This is just a diagramming tool, similar to Visio if you've used that on Windows. There's a lot of different sort of things. I happen to have this one, so I am going to try and use it if I can remember how. All right, so we want to see. Oh, hang on, I got stuff popping up on other screens. It's messing me up. There we go. So here I got some stencils, and these are just shapes that you can drag around. And you can see right here I have selected the entity relationship stencils. These just give you some stencils that are commonly used for modeling essentially schemas or database designs. So I described the problem. We want to create a database that'll track teams and the players in the teams. Now, you need to think about this. The first thing you might think, well, I can just throw all that in one table, like a spreadsheet, and have a list of everything. And the important thing when you're designing databases is not to do that, not to create gigantic tables that contain too much information. You want to have things broken out appropriately so you're not duplicating data, and so that it's easy to reference things. And SQLite is a relational database. Your tables can be all related to each other and often are going to be. So it's important to take advantage of that. So when you hear a problem, you want to break it down into what are essentially the nouns that you're hearing in that sentence to give you an idea of what the so-called entities are that we want. So let me just drag over a couple things here. The first thing I said is we want to track teams. So let's create something called teams. And we want to track the players on the teams. Now, like I said, this is a pretty simple schema that we're going to be building here, but just I'll be going over some of these techniques to give you an idea of how they might apply. So the next thing you think about once you have your high-level entities is, all right, well, what sort of information about these things do I want to save or do I want to track? And they can be whatever matters for whatever it is you happen to be building. In this particular case, I think all teams are going to have a name of some kind. In the case of a baseball team, they're going to have a manager that's kind of in charge of the team. And they're going to have a location that they're attached with, like the Red Sox are attached to Boston, Massachusetts. So to keep things simple, I'm just going to go with those three attributes as they can be called. So I'll just type them down here. And then you get a little, well, this isn't ideal. I probably could find a better tool that would display all this differently. UML tools are great for this sort of thing as well, but you don't need to get too fancy. This is just kind of, really the only reason I'm drawing it here is so you all can see it. Normally I probably would have a notepad in front of me and I'd just be drawing boxes with a old-fashioned pen and paper, but I didn't have a good way to show that. Moving on to the players, same sort of thing. We want to track some information about the players. We don't want to track a whole heck of a lot. So obviously the players are going to have a name. I'm going to track the position they play on the baseball team, and then I'll track their age. And I'm just looking at my questions here. I got Oblio is suggesting I do White Sox players instead of Red Sox players. Ha! I don't know any White Sox players. But feel free to type some in. Our app will be able to handle any number of teams. So now we have our teams and our players, but we haven't really related them to each other yet. And the question is, how are they related? Well, a team can have players. How many players can a team have? Well, it doesn't really matter. It's just that a team can have one or more players. So we want to draw that on this diagram to indicate that relationship. And there's a little relationship arrow thing you can see right here. And I'll just drag that in between them here. Now, the one thing you'll notice is I grabbed the little one that has the this little crow's foot kind of thing here. And this little indicator is saying that a team can have, one team can have one or more players. And that's an important part of the relationship, because you can have relationships that are one-to-one. This would be called a one-to-many relationship. You can also have many-to-many relationships. And that's the lines, however subtle that may be, indicates that. But this is the overall schema design. We have a teams entity, we have a players entity, and we have a relationship between the two. Now, this is not the database. This is the schema. It's a level removed from that. But what you want to do is then take this and convert it into a database design. And how that converts is going to depend on the database engine you happen to be using. But we're using SQLite, so we will convert it to a SQLite database. So to do that, I'm going to drag this off the screen, and we're going to, whoopsies. Mavericks moves the menu bars, remember, so I have to go to the other monitor. There we go. So we'll create a new app here. Now I'm going to create the database using the database editor that's included in Xojo. Now I know this is not really the world's best database editor, and I'll apologize for that, but it will get the job done here. So we'll give our database file a name. And when this brings up the database editor, and this is where we're going to create our tables and the columns that are on the tables, and then specify how they're related to each other. Now looking at our schema, generally speaking, each entity or box that you have on a schema becomes a table. So we're going to want two tables. First one will be called team. And we're going to want columns that are going to map to each of the attributes that we want to store, the important pieces of information. And we had three on team. We had name, manager, and location. One thing that I do when I'm designing databases is I always include a primary key that's an integer ID. This makes it very, very handy to maintain your relationships, and it's all automatically handled by the database, so you generally don't have to think about it too much. But that'll actually be the first column that I'm going to add. So I have a column, I always call it ID. It's a type integer, and I turn on the primary key property here. So that one shows up here. It has a little key icon. And then I can add the other values. So we had name. Now you notice I'm changing that to text. SQLite is different than any other database you will ever hear about or have used in how it handles data types. It actually doesn't really use data types. In any other database on the planet, if you create a column and you tell it its type contains only text or string or whatever, and you try to insert an integer into it, you get an error. And vice versa. If you create a column that is of type integer and you insert a string into it, you get an error. Well, SQLite doesn't really care. It lets you put whatever you want into any column, regardless of what its so-called type is. So it actually only has a few things that it calls types, but it refers to them as a different name. After I'll point you to the web the page of the docs on the SQLite site that talk about this stuff. But the important thing is to stick with the really basic types that they have, which are just integer, text, essentially floating or double, and then blobs. Everything else is just kind of magically converted to one of those types. So I like to stick with text here. You could certainly use varchar. That's one of the things that SQLite will just treat that behind the scenes as text. All right, what's the next one? Manager. And then location. All right, so I clicked the button to save all that. So now we have this table with these 4 columns here. Now I can add the player table to map it to our player entity and add its columns. Again, like I said, I always add an ID as an integer primary key to every table that I create. Now we need to think about our relationship. Player is related to team. And this is where the concept of something called a foreign key comes into play. And essentially what we want to do is we want each player to know which team they're part of. And we do that by giving the player a reference to the team. And since we're using these IDs as primary keys, they are ideal for managing these references or these relationships. So we're going to add another column. I'm going to call it here team ID. And this is going to be what's called a foreign key. And it's going to contain the ID from the team table that this player belongs to. And then we can add our other properties or attributes here. We got name, position they play, and I will add their age. And that one will be an integer. So now the 2 tables are here. Now, I've added this using the database editor here in Xojo. It only lets you create the tables and add new columns and whatnot. You can't actually enter any data here. One of its limitations. It is very simple, but at least it lets you design the database and get it done quickly. But I'm not even going to leave the database here in the project because we're going to connect to it separately. So I'm actually just going to delete it to get it out of the project. You'll see it's still here on disk, which is good because we're actually going to connect to it manually. I'll have a dialog pop up so it can be selected. But you get better results opening the databases from code rather than attempting to access it with it leaving it within the project. That's great for doing little demos, but not very practical. So I figured we'll show you the more practical method of doing that. So we now have a database, and we now have our schema, and we now have an actual database. So now we can create a Xojo app to do something with that database. All right. Scanning some questions here real quick. All right, I'm just going to jump over to SQLite here and show you the website before we get too deep into Xojo. This is SQLite website. The important section you'll want to go to is here in documentation. And you can scroll down to a couple of pages here. The version 3 data types page talks about SQLite's rather unusual use of data types and really the data types that it has here to work with and how everything else is just converted to one of those data types. And the concept of affinities and how it will attempt to use something based on what it looks like, what it thinks the data actually is. And someone had asked me, is there a difference between varchar and text in SQLite? No, there's no difference. There's also no lengths. Some databases you can specify varchar and then you put in parentheses the length. So you'd say 100, and that would mean this column can contain up to 100 characters. SQLite has no such limitation on the length of what you can stick in any of the columns. So this is definitely worth a review. And then the more important thing here is the SQL Syntax Page. And this shows you all the commands that SQLite has. It's a little bit computer science-y, but at least you get to know what the actual commands are, and you can see what they can and can't do. So that's handy. One important limitation of SQLite that other databases can do is alter tables very restricted. You can't, for example, remove columns from a table after you've created the table. You can only add new columns to the table. Lots of little things like that you need to think about when you're working with SQLite, especially if you have experience with other databases. So going back to Xojo, let's create a window here. And what I'm doing is I actually have obviously created this project and I'm referring to it so that I can go a little quicker. But I'm bound to make mistakes, so bear with me. So what I want to do here is have a window that's going to show the teams that are in the database and allow us to add new ones, edit existing ones, and remove them. So I'll just drag a few controls over here. Probably start with a list box to show everything. And we'll also use that for editing purposes. And then I'll keep this simple, just some buttons. And if you've watched me do these webinars in the past, you know I'm very particular about the naming of things. And of course, if you looked at any examples that are included with Xojo, I don't like leaving things at the default names. Makes it hard to work with. All right, we've got general layout. So essentially, I want to tweak the column count here. We got 3 values we want to actually display. And I want to turn on some headings and actually type what they are. So we want to show the name, the manager, and the location. So I can just type these in here, press tab between each one, and they'll fill in as the headers. All right, so that's the general UI layout. I'm going to do what I tend to do and save periodically. All right, so the first thing we want to do is open the database. So we're going to want to add a property to contain our database reference. Keep it simple. We will call it database. And it will just be a simple little property that lives here. And then I'm going to add a method. And I will just call it open database. And this method will be used to actually let you select the database file, because the way we'll build this is you can actually open multiple database files at the same time and have different windows open. And it'll let you choose a database file, and then it'll connect to it. All right, a couple other questions here I'm seeing. Is SQLite public domain? Yes, SQLite is public domain. They don't have any, public domain means it's essentially license free. It can be used with anything, commercial or not, with no restrictions, which is great. That's why you see it used in so many things. It's built into Xojo now, and we first added it back in 2005. But it's built in pretty much every operating system. iOS makes great use of it. Even apps like, I think Firefox uses it for maybe managing the bookmarks or something, or used to anyway, but it's commonly used. Tim says, remove team Florida Marlins. I don't think we'll need to do that. Major League Baseball might end up doing that. All right, so we got our open database here. So in interest of speed, I'm just going to cut and paste some code here and briefly talk about it. All right, so we've got some code here. This is just putting up the dialog to let you select the database, making sure you selected something. And then if so, it creates a new instance of the SQLite database, points it to the file you just selected, and then attempts to connect. And if we did connect, it's enabling the buttons, which actually reminds me I didn't disable them by default. So I want to make it clear you actually have to open the database. So you see I've multi-selected the 3 of them, and I can come right here and just disable them all in one swoop. And then it calls the load teams method, which we haven't created yet, but that would actually populate the list box with the teams that are in the database. and it updates the title of the window with the name of the file that was just selected. So if we run this, and if I didn't make any errors, I already said this didn't exist, and yet I still tried to run it. So we'll comment out the method that doesn't exist yet. And I probably didn't fix locking or anything, but who cares? I'll let you guys, well, after this, I'll have these projects up for you to download, and they'll be perfect, right? So you'll be able to monkey around with them. So right now this opened up. I actually forgot we didn't want to add a menu here that actually says open so that you can open a database. So let's go back and do that. So we'll go to the main menu bar, and I will add a menu item. And we'll just call that file open. And I'll put it here at the top. And then I'll go back to the team, and I will add a menu handler, and I will select file open, and I will tell it to call open database. All right, so now we can actually open the database. With the buttons grayed out, we couldn't do anything. So we could come here, we could open a team, we could get a prompt, and I could pick the database file. Won't do anything because we haven't written the method yet, but there we go. Which brings up the next things we're going to do is load the teams. Now again, we don't actually have teams in the database yet, but we can code up the load method to actually load any if there were any, and then next we'll add the ability to add them. Now before we get too far though, I want to add this little method here. So we're going to use it a fair amount. And that's this little DB error method. We're going to call this after most database commands because it's an important thing you want to do is after you do anything that requests information from the database or talks to the database, you're going to want to check if any sort of error occurred. And it can get tedious to constantly be writing if DB error, then do whatever. So I'm just going to have a little method here that we can call after things that will display an error if one occurred and then return false, allowing us to essentially get out of whatever we were doing. And now let's move over the load teams method. So load teams. This is going to populate the list box with the teams, team names, manager, and locations that are in the team table. So first thing it does is delete any rows that happen to be in there. And that's useful in case you wanted to have like a button called refresh or something like that that would call the load teams method again. You wouldn't want them to keep getting appended to the end. And pretty much every database app I've ever written, I've always forgotten to write this line at the top, and then I start monkeying with it, and I end up with all kinds of data in there, and I get annoyed that I forgot it yet again. So we want to get the data from the team. Now we're starting to talk about SQL, structured query language, which is the language used to communicate with databases. SQL is not standard query language. It's structured because there is not much standard about it. But for these simple things, it actually won't change a whole heck of a lot. The big command is select, which is going to say, select some information. You would list the names of the columns that you want to get back, or you can put an asterisk here to say, just give me all the columns that are in the table. So instead of that, I could have had ID, name, manager, location, written like that, but that's longer and scrolls off to the right, so we'll just leave it like this. But it's important if you had a more complicated database that had a table that had a lot of columns on it, which is certainly not an unreasonable design depending on what you're storing. If you're not showing all the information, it doesn't make sense to select all the columns and then only show like 3 of them. So most of the time you're going to want to just pick the ones you intend to show. But we're using all 4 of our columns. The from is another keyword. And SQL is often written like this with capitals, all caps for the keywords. Team is the name of the team, and then the order by clause indicates how it's going to be sorted, and essentially this says just sort it by the team name. So that's a simple SQL statement, and then you fetch that using a record set in Xojo. So we just created a record set here, and then calling the SQL select command of the database, which is our property, we pass in the SQL string, and we get back a record set. Now immediately, checking if there's database error by calling our little method. And if there was an error, it will pop it up on the screen, and it'll just return out of this load teams method because, well, we can't do any more if we found an error. And the sort of things that would generate an error would be, in this particular case, a mistake in your SQL, typing teams instead of team, which brings up an important point. When I named everything, I used singular names. I didn't call the table teams and players. I called them team and player. That's just more of a style thing. But the important thing, like I mentioned often, I think, is be consistent with your style. So it would be very bad for me to call teams plural and then players singular. That's just confusing in bad form. Pick one and stick with it. All right, so we check if there's an error. And then here, as the comment says, we're going to just get each item from the record set, so or row as a row of the team. And we're going to add it to the list box. So we make sure it's not nil, and then we loop. And we loop until we've reached the end of the file. Oddly, that's called end of file instead of end of record set or something, but I'm sure there's historical reasons for that. And then we just call an add row to add the row to the list box. And we're fetching from the record set each column. And I'm fetching them by name. So I'm using the field method and supplying the name of the column. And I'm getting the string value because that's what you want to show in a list box. And the next thing I'm doing is I'm saving the primary key. But we don't need to see it. I don't really care if the team has a primary key of 1 or 1,000 or whatever, but it is going to be used. So you want to save it somewhere behind the scenes. The row tag is perfect for this sort of thing. So here I'm just stuffing the primary key into the row tag. And we do this for however many happen to be in there. So now I can go back to the open database and I can uncomment this because we now have implemented the method. And again, I can run it and you can watch in its glory as it doesn't do anything because we still don't have any teams in here. But at least we shouldn't get an error. And that is part of testing to make sure you don't get errors. So what's the next thing? Well, we want to add teams. Well, we've already added a button to add teams. So let's add its event handler. All right, so the add button is going to add a row to the team table. So again, I have pre-written code here, so let me just paste this in. It'd take way too long for me to type, and I'd make mistakes upon mistakes. All right, so here we go again. We want to insert a row into the database. Now, the way that I've kind of designed this thing is when you hit the add button, it immediately inserts a row into the team table. And it's kind of a dummy row, if you will, that you then edit. And we're going to use the inline capability of the desktop list box to edit the values. So what this is going to do is going to immediately add a row to the list box, or I should say add a row to the database, then retrieve that row from the database so it's displayed in the list box, select the newly added row, and then make it editable so you can type in new information. So the first part is to actually insert the row into the database. And the SQL command to do that is insert into, and then you specify the name of the table, the column name or names that you are have values for that you're inserting. In our case, I can leave the manager and the location blank, so I don't need to specify them, but I do want to give something to indicate that a new team was just added. So we'll insert the string new team into the name column of the new row that we just added. And then we execute that SQL command. You'll notice this is calling SQL execute instead of SQL select because the insert doesn't actually return anything. And that's really the only difference between SQL select and SQL execute. One's for SQL commands that return information back, and one's for SQL commands that do not. Again, checking our little error method to make sure that this worked properly. And then we call here this neat little method that is on the SQLite database class, last row ID. This gives us the actual ID of the last record that was added to the database. And that's good information because we're going to want to use that. Then we reload the teams using our previously created load teams method. And then we can scan through the list and check the row tag, which we're saving, containing the primary key, to see if it matches the last one that was just inserted into the database. And if it does, we save it, get out of the loop, and then we call the edit cell method on the list box for that row. And that puts that row in edit mode. And we haven't actually written any code there, so we can actually make changes here, but they won't get saved to the database. So let's run it after adding this and see what happens. So you can see it added the row, first one's in edit mode. So now the next thing we'd want to be able to do is actually type here and then probably press the tab key and be able to go to the next column and have these, as you move from field to field, have the database data get updated. All right, so to do that, we go to the list box. And since we're in inline editing mode, we want to look at the cell action event. And this event is called when inline editing mode essentially ends. So typically if the user presses return in the field or tabs out, it changes the focus or whatever. So in here, we can say, okay, we now know that some editing was done here. We can take that information and update the database with it. All right, so more code that I cut and paste because it takes too long to type. One thing we're going to see here is we're going to use a different form of SQL. This is called an update statement. And this is used to update an existing row in a table. Now you remember we inserted the row previously, just some dummy data. Inserting adds new rows to the table. Update updates rows that are already in the table. So we're updating the team table, and we're setting, using the set part of this command, a specific column, and that will vary depending on which column was just finished being edited, to a specific value where the ID equals the current primary key of the row we're editing. So lots of things here to substitute. Well, first, this one here is just a simple string or string replacement that we're going to do, and we're just going to check which column we happen to be editing. 0, 1, or 2 in the list box, and we're assigning it the related column in the table. So column 0 is the name, manager, location. And we just replace that out. So this would say, if we were editing the first column, this would end up saying set update team, set name equal to, and then it would have these little question mark placeholders. Now the question mark placeholders are here because this is using what's called a prepared statement. And this allows you to essentially have SQLite insert these parameters for you. You don't need them. You could be doing complete string concatenation to stuff these into the string and then send that completed SQL statement off to SQLite, and that will work perfectly fine. But prepared statements are a lot nicer because you don't have to worry about quoting things. And they're also a lot safer, especially when you're dealing with web applications, because they get around the problem of SQL injection, where bad people can type in things that end up being commands that would get inserted in your string concatenation and cause your database to do things that you really don't want to happen. So this kind of circumvents that. It's not really any additional work. You create a new SQLite prepared statement, and then you assign it the SQL using the prepare method of the database. And again, we're calling our error check method because we did something here. And then you bind and set each of the parameters that are specified here, and you can just do them in order. I could jump around, I suppose. It's asking which one to put in, but we'll go in order. So we're binding the first one, so that would be 0 because computers like to count starting with 0. And the first one is a string, so we're setting it to the SQLite text type. And this is just a constant on the SQLite prepared statement. And then we're binding, we bind the type, and then we're binding the actual value. And the value is what the user typed in the cell of the list box. And we do the same thing for the ID, except that is an integer, and that value is in the row tag, that handy place where we're storing the primary key. And after we've bound these two things, we can call the execute command to actually execute the now built prepared statement, and then we're calling to check if there are any error that occurred after that. All right, so hit the save button, hit the run button, see if I forgot anything or if this will let us edit a team. So we haven't implemented any editing. That doesn't do anything yet. So we should only be able to edit a new team. And we didn't implement any ability to tab to new columns or anything like that. So essentially all we can do is edit the name. And we didn't get any errors, but the question is it's actually saved to the database. Since we didn't implement a reload thing, the easiest thing to do would probably be just to quit and rerun. And there we go. We can see that our edit did change the team name, and the first one that we did that we don't yet have a way to edit remains here as well. So we now have 2 teams in our team table. Yay. So moving right along, because time is ticking and I'm going to be losing my breath. We want to implement the edit, or continue along our edit. So the next thing we want to do is have some ability to just tab between the fields. So where is our list box? Here we want to add one more event handler, and that is for the cell keydown event. And essentially here we're just going to check if tab is pressed, and if so, move to the next column. So if tab is pressed and we're not at the last column, we'll move to the next column. And if we were at the last column, we'll move back to the first column. So it allows us to tab between all the rows that we are currently editing. And then because this just allows us to change the focus to the different fields, we don't have to actually change the action event because this already handles different columns being selected. And one thing to simplify here is we can add, so we don't have to keep quitting and reloading to verify things. Well, let's add a refresh here. All right, so we can open up our database. Oops, I didn't input the, let's implement the edit button so we can actually edit the 2 teams we have there. Edit button code is really simple because we're just telling it to edit the first column. So there we go, we're editing the first column of the selected row. So I can click on a team, I can edit it. I don't remember how to spell his name. All right, and then I could click this one and I could tab here. And then the refresh button does a reload. So if these didn't save properly to the database, they would disappear. So those did get saved. That's great. And the last thing would be the remove button that will allow us to get rid of teams. And let's see here. This code uses yet another form of SQL called the delete. And the SQL syntax is delete from table name, where, and then you specify column criteria to match what you're looking for. And primary keys are great ways to identify and look up things because they're unique. There's only 1 per row. You're not going to accidentally delete 2 rows when you meant to delete 1. So again, another reason why I really like having primary keys on all my tables. So here we're just making sure a row is selected. If so, we're getting the ID from the row tag. We're putting together some SQL that says essentially delete the row that has that ID. Again, using a prepared SQL statement. Slightly different variation here. We're only binding the type, and the type is an integer, so it's the same as before. But in the SQL execute method, I can pass in the value here. A little bit simpler than having the other full-blown bind command. And it's able to infer the type based on what you passed in. For simple stuff, this can work great. If your types are a little crazier all over the map, you may not get the exact type mapping that you want. So pay attention if you want to go this route to make sure the behavior you're getting the behavior you expect. Again, checking for an error, and then we're reloading the teams after we've deleted one. And we can see that in action by just adding a team here. Marlins, I have no idea who the manager is of the Marlins. You can see on a refresh, we can click remove. Now it's gone and remains gone. So Marlins have been contracted. All right, so that's the team table. The other aspect of our little app here is the players. So in interest of simplicity, I'm just going to create another window here. And it'll be the player window. Odds are if you may be creating this app, you might want to do this all in a single window, maybe use some container controls for each of the things and just swap between them, that sort of thing. So what we're going to implement here is on the team window. If you double click on a row, we'll open the player window and display all the players that belong to the team that you just double clicked on. So we'll add a little bit of UI here. And I don't know that we'll have time to implement all of these buttons down here, but they're going to end up working almost exactly the same as what we already did. The big difference will be loading the data. Oh, I didn't want to make that a cancel button. So this would be the add button for this window. Like I said, I don't think we'll have time to implement any of these buttons, but let's see if we can actually, well, maybe the add button. But the big thing is to understand how the players are retrieved. So we're going to want to add one more event handler here to the team list, and it will be the double click event handler. And when you double click on a team, it's going to verify that you had a row selected, and it's going to open up a new player window and set the player windows. It's going to have a property of the team ID, which we'll set. We'll also set the database on the player window since they're specific to each of the windows rather than global to allow us to edit multiple things at one time, and then we'll display the player window. So that means I need to add a team ID and database property to player window. And since we're changing them, they'll need to be public. All right, so this won't do anything beyond test. Double click capability, but I double clicked on it, player's window popped up. It's not showing anything because we didn't implement any code to show anything. But the player window is going to want a method very similar to the load teams method that loads the players. So let me grab that. So the load players method is essentially going to say, all right, give me all the players from the players table that have the team ID that we've just set, so that belong to the Red Sox or belong to the Cardinals or whatever. So again, the SQL for that is a select statement. The addition is we're saying, get all the player values where the team ID matches the team ID value. And again, it's using a prepared statement like we did before, binding the type, and then calling SQL select and passing in the actual team ID. I'm trying to think here what I'm missing. Oh, yes, the team ID is actually a computed property. So I just want to see. Oh, yes, that's right. So let me move that over. So that has a little bit of extra code here we'll want. And we'll change this to be the private backing property of the computed property. And fix that name. All right, so what we're doing here with the computed property is when the team ID is set, we're setting the backing property, and then the players get loaded. And then there's just some SQL here that will update the window title with the team name, because the ID is just a number, and it doesn't know the actual team name there. So we'll go back to the database and we'll say, hey, give me the name of the team that has this ID. So load players here does the same thing, gets the values, gets the select statement, does the same loop through the record set, stuffing the values into the list box and saving the ID in the row tag. And again, running this won't actually display any players. Oh, I forgot to move over our DB error method. Not the best idea in the world to start replicating methods like this, but gotta be fast. So now if I double click something here, we get an error. Always good to get errors when I'm doing this. Oh, well, why did I get an error? It says that the DB is likely nil, but I thought we passed that in. And while I'm pondering my bug, I'm going to look at this question here from Tim. He's asking, since I'm internally generating the SQL statement versus getting the data from the user, prepared statements is mostly guidance rather than a necessity. And that's a good point. The SQL injection that I mentioned earlier is really only an issue if you're using user-entered values along inside an SQL statement. All of the SQL statements that we've used so far here are all embedded in the app itself. The user doesn't provide values that are used in them. So yeah, prepared statement isn't helping you with SQL injection because it's not possible to inject any SQL because it's all in the app. If you had like a search field or something like that, then yeah, that could pose that risk. And then just in general, prepared statements, probably not a lot, but could be a little bit faster depending on the database engine. They probably don't make a heck of a difference with SQLite because it's so small and fast already. But larger database servers, the server itself can cache SQL statements that have been generated in this way, and that can improve performance at times. All right, so it looks like I need to set the database for the ID, since this is a computed method that actually runs some code that expects the database to have a value. Let's reverse that. All right, you can see the only thing that worked here is that it actually put the team name up here in the title. So it says these would be the Red Sox players. All right, so the add button is going to add a player and is going to work pretty much how the add button worked for adding a team. Same sort of thing, insert into the particular table. The slight difference here is that we're specifying two columns, because not only do we want to insert a generic name to indicate this is a new player, but we have to relate it to the team. So we have to specify the foreign key, which is our team ID column, and we need to put that in the SQL here. And you can see, as Tim noted, I'm actually doing this one using simple string concatenation because I think I was getting lazy. But anyway, either way, it does work, and this is how one would look if you were doing string concatenation. These can get a little unwieldy if you have a lot of things and you try to go this route, and particularly if you're inserting strings that have to be quoted, and then you end up with lots of quotes embedded in strings that can be hard to pick out. So make sure your code always remains readable. So once you get the insert statement, the rows inserted, and then the same sort of thing, load them back, select the one that was just added, and then put it in edit mode. And this will have the same situation as before. We'll be able to add players, but we won't be able to change their names right away because we don't have any edit code in here. So if I close the window and reload, we'll see the name stays what it was originally inserted in the database as. But as you can see, that's the general pattern. Checking my time here. All right, I'm now gonna switch gears to just show how this would look in a web app real quick. I'm not gonna implement the rest of the buttons on the team, on the player window, just because it's pretty much a lot of the same stuff. Let's see, and I'll take a look at the questions here. I got a question about handling blobs and or pictures. How do you insert, update them? Well, blobs and pictures are essentially the same thing. That's binary data. You would insert or update them the same way, depending on the size of the blob. With SQLite, we do have some extra capability there to allow you to load up blob or pull down blob data in chunks, which can matter for really large blobs. But for smaller things like maybe pictures or something like that, you can just assign the blob value the same as we've been doing right now. You would set the bind type so that it's a blob, and then you would assign it the value. That would work the same way. No real difference there. I'm showing you how to do these things. If we go back up here to the where would that be on the action event, where we have the update using a prepared statement. Xojo also has the ability to do what's called record set edits. So you could actually, in a select statement, call record set.edit and then use the various properties to actually set values that way. And I think there might be some examples included with Xojo as that. And that's another way you can go, and that's also an easy way to set blobs. And what's the best data type to map a blob to in Xojo? Well, it depends on what the actual blob data is. I mean, if it's a file, you would probably pull it out and save it to a binary file on the disk. If it's a picture, you could throw it into a picture. It's going to depend what it is. And then another question about prepared statements. Is it a standardization of what have to code manually? Well, I don't know that prepared statements are just an implementation of something that database engines provide as a way to make it easier for the mapping of values into the SQL statement. It's just a little bit of a safety net and a little bit of a performance improvement. And on the SQL injection side, it's a big safety net, and it's especially necessary when you're dealing with web apps where anyone can access it, and if you're building SQL statements, you can take user input data from anyone. There's a much bigger security risk there. So I think that we probably added the prepared statement stuff about the same time as the ability to add web apps was added as well. And then one last question here. Can you save a file into a blob in the database? Oh, yeah, absolutely. You can, just pull in a file as a binary pull in a file using a binary stream and then save it as a blob into the SQLite database. It absolutely works. One thing to remember, though, is, SQLite's called an embedded database. It runs locally. I wouldn't go stuffing that thing with a bajillion giant binary files and bloating the size of the database. That may not give you performance you want. And certainly if you are putting a lot of blobs into a SQLite database, and probably with any database in general, it often makes sense to have a separate table just for the blob data and have it relate to the main table, rather than having your main data and the blob data all in one table, because that can slow down performance when you're querying it, even if you're not necessarily querying the blobs. So but that's just general database design concerns. All right, so let me switch gears here to my web one that hopefully I can whip up real quick here. And this one, since we don't have a lot of time, we'll just essentially pull in the team names and show them on a web page. But I think we'll be able to use most of the code as is. All right, so we want a list box here. Three columns. Give them their headers. All right, so I'm going to see if I can remember what code I want to move over here. And I'm going to call this So we're definitely going to want our little DB error method. And our load team method. And I'll add a couple of event handlers here. Open and shown. So in this little simple thing, I'm just going to essentially have the open event handler connect to the database. And then the shown event handler will attempt to load the teams up into the list box. So, whoops, I put that in the shown and did the complete opposite of what I wanted. There we go. So, just opens the database file. Use the right name for our example. And attempts to connect to it. And if it can't connect, it's going to set this property on the page. And then the shown event handler will, if there's an error, show a page that says there's an error accessing the database. Otherwise, it'll load up the database. And our error page can be nice and simple. Oh, I'm not getting my paste thing. There it is. That'll just say we couldn't connect. Nothing too fancy there. Now, if we were, well, let's save this and then we can run it. I'll save this one as binary. I'm getting a lot of files there. I expect we'll get a database error because the file, well, eventually, if we fix our other errors, since I didn't add the DB property, that will definitely give us an error. Yeah, we haven't moved the database anywhere that the web app can see it, so that will definitely cause an error. So we're just going to add a copy files build step here to tell it to copy our database file alongside the app. And there we go. It pulled in the two names we had typed in for teams and displayed them here. Now, if you go back and look at that, you'll see the code in these two methods we moved over is exactly the same as the desktop code. This error thing is nothing terribly sophisticated here, but it is the exact same code. And but the load teams code is also exactly the same. Where this would start to deviate, of course, is where the web side doesn't have the same capabilities in the list box that the desktop side has. In particular, there's no inline editing on a web list box. So you need to think about a different way to allow the editing of data. And it could be like a dialog slides down from the top of the web page with fields for each of the columns, and you enter and you hit a button that says save, and then they get written back. So, I mean, something like that could definitely work. Or you could have the fields right on the main page. Lots of different options there, but you can't do the inline editing, unfortunately. But the database code and the talking to SQLite is going to be exactly the same. The important distinctions to remember, though, is that desktop apps are single user. Web apps are by definition multi-user because multiple people can connect to a web app. So you're going to want to create your database connection for each session in your web app. Now, normally that would mean here in the session object, you'd add like an open event handler, and when that gets called, you'd create a new database instance. In this particular case, I put it on the open event handler of the page, which serves the same purpose because you get a new page for each session. But if I were designing a larger app, it might make more sense to move this connection code back into sessions so that it's more easily reusable throughout all the pages in the web app. And the other thing that's generally preferable to do when you're dealing with web apps is to set the multi-user property to true. And because, you know, web apps have multiple people connecting to them at one time, you want to make the database access be as fast as possible. And what multi-user does, and it's not technically named as great as it could be, is it doesn't necessarily enable multi-user access because SQLite can only ever have one user changing any data in it. Multiple people can always access it and read the data, though, whether or not this property is true. What multi-user actually does, and you can read the language reference for the specifics, is it turns on a feature called write-ahead logging, which essentially greatly improves the performance of your database writes so that they don't take as much time writing to the disk. Because if you try to have two people writing at the same time, one of them will essentially get a lock on the database, write their data. The other person will get an error back saying database is locked. So you want these writes to happen as quick as possible. You don't want a write to take, you know, several seconds. That would be bad. People would start getting database errors. You'd have to code up your app to check for these and then to retry the write after a short period of time and that sort of thing. And that can get to be a hassle. And you're probably going to want to do that anyway, but multi-user definitely improves the performance. And you can use multi-user on a desktop app as well. And it would probably improve write performance. It creates a few extra files alongside the SQLite database file. But there also may not be any reason to, but you can change it and see if it makes a performance difference in your applications. All right, we're a little over. I'm going to scan here for any questions and then probably call it a day. And the question here is, if the database is saved on a web server, how would you connect to it? Right, you'd put the database file on the actual web server, and then you would connect to it by, like I'm doing here, just, you know, refer to its path wherever you happen to put it. You can see here when this is running, the database happens right now to be living right alongside the running web app because our build step copied it there. But, you know, wherever you happen to put it on your web server, you just need to make sure you have write access on the web server for the running app, and then it doesn't really matter. You just hard code the path access to it in your web app. All right, like I said, I'll get these examples packaged up along with the recording, and these will show up on our website and on the wiki and whatnot for you to download and play with, and they'll probably also be in future versions of Xojo as well. There is a whole database chapter in the user guide that covers, there's a section that covers SQLite, and we cover all the other databases as well, so you probably want to read that. Other things regarding SQLite are covered in there, like its encryption and the ability to handle its backup mechanism and other stuff. And let's see, I got one more question here from John asking if there's any performance issues between opening the database once per session or opening and closing it each time it's needed. Opening and closing SQLite is pretty darn speedy, so there's not really big performance issues with opening and closing it each time it's needed. I mean, it's more of a convenience thing. I mean, if you open it once at the beginning of the session, you kind of know it's available and you can use it anywhere. If you're opening and closing it throughout your app on various pages when certain functionality needs it and then attempts to open it, I mean, you can design your app so that you have methods that kind of do that all for you automatically behind the scenes. It's more of, you know, what you're comfortable with. But when you're dealing with SQLite, the connections don't really disappear. Now, if you're dealing with a database server, that would be a different thing to consider, because, you know, database servers may or may not be on the same server as your web app. They could be on their own database server elsewhere. And it's possible the connection goes down or something like that. So you do need to have the ability to reconnect and check for error on the connection. All right, I will remind you all to check out the SQLite website here at this URL for all the specifics on lots of cool things that SQLite can do. I only briefly touched the top here. There's all kinds of pragma settings that you can tweak. You can create in-memory SQLite databases that don't actually have a file behind them that can be used for storing temporary information. You can create virtual tables. You can create full-text search. It's an incredibly powerful database for such a simple thing that is quite so fast. So certainly consider it for a lot of needs. It can be you can use SQLite as your document type for your app. So rather than saving an XML or text document, you could actually be saving a SQLite database, and it could have all your app's data in it. Very, very flexible. And before we wrap up here, I want to remind everyone that our conference next year is in Las Vegas, and we just recently posted the session list. It's not 100% complete, but I think over 30 of the session titles are now available with descriptions and who's presenting. So definitely check this out, scroll through here. I know we've got several database related topics that are being presented by various people. I'm doing like 5 sessions, so if you want to see me present in person, this would be the place to be. And of course, we also have a database-specific topic on our forum. That's a great place to ask SQLite or any database-specific question. So I want to thank everyone for attending. The recording and the examples for this should pop up on YouTube sometime this week. And next week will be our first 2-part webinar. And we'll be walking through building a text editor. So that should be a lot of fun. So thanks everyone for attending. Have a great rest of your day.